Hello, hello. So in this video, we're looking at how to do binomial expansion for a particular expression like this. So as we said in the intro video, if the power, this power here, is a positive integer, then you can use the more simple formula. But if it's a negative number, or if it's a fraction, or if it's a negative fraction, then you have to use this formula here, which is not particularly hard to use. They give you the formula in the formula booklet, and all you have to do is plug in the correct numbers. So it's really not too bad. It's just a lot of things that you have to plug in, and so this is really easy to make a little mistake. So what we're going to do is just explain how to do this question here. So this one says, find the binomial expansion up to and including the x cubed term for 1 plus x to the power of minus 5. And then we also need to state the range of values of x for which the expansion is valid. So two things here, really. So for this bit here, the first thing we want to do is find the formula. And this is in the formula booklet, so in the exam, you don't really need to write it down, but you do make sure that you find it. I would always use the one from the formula booklet rather than try to remember it in your head each time. Then what we want to do is identify what our x and our n is. So when I say our x, I mean this bit here. So you see how we have a positive x. So I'd say that our x in this expression is just x. Yeah, it's not 3x, it's not minus 2x, it's just x. And then our n is our power. That's this bit up here. Yeah, the minus 5. So you don't have to, but I would always write these two out. And then for step 3, all we do is substitute these into the formula. So my 1 plus x to the power of minus 5 is going to be expanded as 1. So I'll keep this 1 here. Plus, and I have n times x. So n is minus 5x. And for now, I'm going to put the minus 5 in a bracket like this. And then the x. This bit here, we have the n, which is minus, well, actually, I'll put plus. So we're going to add this term here. So n is minus 5. And then n minus 1 is effectively minus 5 minus 1, which is minus 6, but it's up to you whether you would want to do that there and then, or you can just write this and simplify it afterwards. It's really easy to make a mistake in these sort of questions, so sometimes it's better not to try and simplify things straight away, just write everything out, put it all in, then go through and simplify it all afterwards. And then on the bottom, we have basically 2 factorial, which is 1 times 2. So 1 times 2. And then we also need this x squared. Now, often you'll see them write x in a bracket squared. Here we don't really need to because our x is just x. But if x was something like 3x, then you would want to put the brackets because it's the whole 3x being squared, which would come out as 9x squared. So as a convention, I'd pop the x in a bracket like that. And then we just need to do one more term. So they haven't really told us what to do because this is the very last term. But basically you do n, then we do so we do our n, which is minus 5. Then our n minus 1, which is minus 5 minus 1. So I'm actually going to simplify it this time. And then we do that minus 1 again. That becomes minus 7. And that's all going to be over this time 1 times 2 times 3. Yeah. So basically you just keep on taking away 1 from your n, and that's what you have on the top. And on the bottom, you do 1 times 2 times 3, and then the next time you'll also put times 4, and so on. And then we're going to have the x to the power of 3. So if we then simplify that, we've got a 1 minus a 5x. And then here we do minus 5 times minus 6 is positive 30. Positive 30 divided by 2 is 15. So I might actually just not try and simplify those, but top bit is 30, bottom bit is 2, we get x squared. Then over here, minus 5 times minus 6 is 30, times minus 7 is 210. So I get minus 210 over the bottom bit here. 2 times 3 is 6. And then we get x cubed. And I'll simplify that again. So 1 minus 5x plus 15x squared. And then minus, we got plus, and a negative 35x cubed. Yeah. So this here really, like how much you simplify and how much you just leave for the next step is entirely up to you. It's all personal preference. I really do it differently each time. Like if I think something's quite easy, then I'll simplify it there and then. If it seems a bit harder and I think I might make a mistake, then I'll just plug the numbers in exactly and I'll simplify in the next step. So it's just whatever you're comfortable with. But that there is it. We've now expanded this up to and including the x cubed term. Okay, so the last thing we need to do is find the range of values that our expansion is valid for. And just to remind you, our equation was 1 plus x all to the power of negative 5. That was our expression. So what you do here when you find what it's valid for is you take your x, which in our case is just x. We don't have 3x, we don't have like minus 2 over 3, we just have x. You stick in a modular sign, and you say that it's less than 1. And that's it. So R1 here is valid for when the modulus of x is less than 1. We don't have to do anything more. Just to give you another example while we're here. If our expansion had been 1 minus 3x over 2, and this had all been to a power, then when we had to find out what it was valid for, we would have done minus 3x over 2 modulus is less than 1. And then you have to rearrange this. So you get rid of the minus because it's a modulus, so it doesn't really make any difference. And we'd have 3x over 2 modulus less than 1. Multiply both sides by 2, so that you get 3x modulus is less than 2. And then divide both sides by 3, so the modulus x is less than 2/3. Yeah. So this is generally how you do this sort of question. Always wasn't very relevant for ours because we just had x, in which case it's always is less than 1. But if it is something more complicated, then you have to simplify it down. So anyway, I'll just get rid of all that because this is not relevant to our question. But I hope that all makes sense. But yeah, that's it. So important things, just write down the formula, or just make sure you find it in the formula book. Write down what your x and your n values are, substitute them in and simplify it, and then do this thing to find which range of x values it is valid for. And that's it. If you have any questions, then let us know down in the FAQ, and otherwise I'll catch you in the next video. Thanks.